Welcome to this Unreal Engine tutorial. Today we will be looking at actor components. So let's jump into it. Here we are inside Unreal Engine 5 Early Access. This is a tutorial, of course, that will work both in Unreal Engine 4 and Unreal Engine 5. So there's no difference between them for now when it comes to this. So a little bit about actor components. Now, actor components is something that you have already come in contact with, knowingly or unknowingly. If you were to look at a third-person character, for example, you see that it has a character movement component. This is an actor component. You can see actor components as sort of self-contained bits of functionality that you can attach to any kind of actor in the world. Now, some actors might not be meant to handle certain components. They might be built for specific things, like maybe if you have an XP component, you might have that on a character, but it doesn't make that much sense to put it on a box maybe. Things like that. But generically, actor components are meant to be coded in such a way that they don't expect too much of whatever they're belonging to. So you have to be a little bit mindful about where you place them on what kind of actor, but you should also be a little bit wary about how you program your code inside the actual component, so that you are actually not making too many assumptions and doing something that is possibly not allowed. Now, the best way I think for us to actually get into this is to actually start making a component, and then we'll discuss a little bit along the way. So I was thinking we will make one or possibly two components. We'll see how it ends up. But to start off with, let's grasp the concept of hit points, for example. In Unreal Engine there is a concept of damage. There are built-in events that handle applying damage to different actors. But there is no system for health. So one way you could do this is by, for example, creating a component for health. So let's start with doing that. So if we just right-click and create a blueprint class, you know that we have these common parents that we can choose from, and the actor component is one we have available to us. So we'll click that one. And let's call this BPC for blueprint component. So we have a naming convention to separate it from other naming conventions that we have, or to keep it from other objects that we might have. And then we underscore it and we say HP underscore system. So this will be our hit point system. Now if we open up this blueprint, it looks basically like any other blueprint that we have come in contact with before. There are some things you should keep in mind. You should probably not... let's say we have this third-person character and we want to apply this component to this character. So let's just do that immediately, and we'll go... let's see here, we want to have... Does it not show up? Let's save. Maybe let's compile this. It seems to be compiled, saved. Let's close this down. Third-person character. BPC. Okay, BPC, HP system. Maybe I didn't just see it the last time. So anyway, we can just name this our hit point system, something like that. So now we've attached our component to this third-person character. What you do in the actor component generally, when it is meant to talk to whomever it is belonging, you don't assume too much about what kind of class it is. But when we say that begin play here, for example, let's say we do a get owner. Maybe it's context sensitive. Get owner, like so. So now it's gonna reference itself and say, who do I belong to? It's going to go up in a chain of hierarchy when it comes to ownership. And that will allow it to find the third person character here. Now, This actor that we get out here is, like it says here, it is of the type object actor object reference. So this is an object, not a third person character right now. Although officially it's a third person character, if we were to put this on a different character or a pawn, for example, then it would not be a character, right? So you could do something like cast to third person character, and then when that happens we could, for example, print and say we belong to a character. Now if we play, we'll see we belong to a character up in the top left there. So that works. The third person character and the blueprint component here for hit points that we've made actually work. They communicate now. But if you were to want to have this on things that doesn't have a hierarchical a common hierarchical like tree, some common parent class that they both have, like for example we have a player that's of third person character, but we also have maybe an animal in the world that is able to get or it's meant to keep track of hit points, then we wouldn't be able to cast to that, because that one might not be a character at all. It might just be a pawn as its parent class, although that means we have pawn as our common class in this case. But it might be that we don't have that, so we need to be always a little bit restrictive in how we code our logic, depending on how we want to use it, of course. If you wanted to use hit points for trees also, to make sure that when you're chopping trees that you need to reduce the hit points to 0, then again that's probably not a pawn even, that's just going to be an actor. So yeah, the thing that you might want to do instead then, to make sure that your coding interaction, the act of communicating between the blueprint component and whoever it's attached to, is to make use of interfaces. So then you could say something like, let's create a blueprint interface just so I have something. Blueprint interface, call this, whoops, let's call it hit point system, just to be super clear about what functionality this is connected to. This might not be a great name for this specific case, but anyway. And then we'll have something like print current hit point, for example. Then we go back to our blueprint. Now, if we were to say our owner here, and then say something like implements does implement interface, and then we choose BPI HP system, we would get a boolean from this, so we could make a branch checking against this. So this means that we could now have an owner here that could be an actor, it could be a pawn, it could be a character. As long as it implements this interface, then we know that we can somehow interact with that. Meaning that we could, actually let's bring back our print here saying that HP system online exclamation mark. And then we compile, save and play, and we'll see that nothing happens. And the reason for that is we said that this should be only happening for something that implements the interface, and the third person character is currently not doing that. If you are not familiar with interfaces, I will try and keep a link to an interface tutorial in the bottom so you can watch that and get up to speed. But let's assume that you know about interfaces for now. So we go to class settings and we say add on interfaces here, and we say BPI HP system here. Compile and run again, and now it's saying that the HP system is online, because now this character is implementing this interface. One benefit of doing this is not having to keep track of what kind of class you're actually communicating with. Another one is that no code will actually break if you put this on something, because if the owner of this component doesn't have the interface implemented, you saw nothing would just happen. It's nothing would break down, nothing would crash, nothing like that. That's another benefit of using interfaces for this kind of communication. Anyway, moving on, let's say that we wanted to keep track of hit points in here. That makes sense since it's an HP system. We'll make some variables. We'll make current HP, make it a float. And we'll make another one and we'll call it max HP, which will also be a float. And then we could have something like the point of an HP system is generally to keep track of is a character alive or is it dead, right? So if we were to say, we make a custom event in here, we call check alive or check dead. Actually, let's make it a positive, not in death being positive, but as a Boolean expression. And actually, let's not even make it an event. Let's make it a... let me think. Actually, an event should probably be fine. Let's do that again. A custom event. And I'll explain a little bit in a moment here. So check dead. So the point of this would be to check if current hit points is less than 0 generally. Right? That is generally when you consider something to be dead, when it has fewer hit points than 0. So we'll just make a small check like that, and then we'll do it so that we will print out something that will say we are dead. Now, to be able to test this, we actually need to be able to reach an HP of lower than what it is having right here, right? So we need a way to decrease our hit points. So let's make a custom event called change health. And we'll take an input that says is called hit point change. We'll make it a float. So whatever value is coming in here will change our hit points. So this could be used both for healing and for damage. So a positive value would give us hit points, a negative value would decrease our hit points. So we can just say current hit points plus whatever hit points we're getting in here, and we set that as our new hit points. However, we probably want to, actually let's change this as well. Let's make this to, instead of comparing against 0 over here, we want to compare against less or equal to 0. So having 0 is also meaning that otherwise we need a negative value here, right? So that means that we can use this value over here and we can clamp this float, meaning that we're only allowing it to go between certain values. So the lowest it can go is to 0, the highest it can go is to max HP. Like so. So after that we actually set it to whatever it has been clamped to, and after that we check if dead. Like so. So now we have the functionality of if this gets called and it changes our hit points to the point there where our current hit points is below or equal to 0, then we will type out that we are dead. Okay, let's try and fix so we can actually do that. So let's go to all classes and get a pain causing volume. Oops, I might have clicked something else there. Let's try this one more time. Pain. Okay, I managed to get it even though it was switching quickly. So let's do it so that the word third here will actually be where we have our pain causing volume. Now, this allows us to go in here and take damage. You can see here damage per second, and you can also change your intervals for damage. And this is just so we have an easy way of checking this. This is not how you would want to do it in your game, but this is just to check the functionality for this. Now, what will happen now is our third person character walks into this, it will get prompted about it should be taking damage, but nothing will happen when we walk in here. It's just like standing anywhere else. We need to have some way of handling that input, and what is using that is damage. You can see we have some events here for event any damage, point damage, and radial damage. So this event for any damage will be called for any type of damage. And just to check that this is working, we can print out here that I took damage. And the damage that it's taking is the damage input over there, but we'll leave that for now. So now that we walk in here, we can see our system is HP system was online there, and now we can see that we're printing out that we're taking damage all the time. Okay, so that's fine. Now let's use that with our HP system then. So if we take our HP system now here and we say change health, and then we say that this multiplied by -1, because this is damage, remember, so we need to actually have it as a negative value if we want to decrease our hit points. Then this should be changing our hit points downwards. Now, we're only taking 1 damage per second, and our third person character, actually our hit point system, has a default of 0 hit points for current and a default of max hit points for 0 as well. So what we might want to do is something like, let's set our max hit points to, actually let's not do that much, let's do 10 hit points. 10 hit points is our max, and when we start up, let's say that our current hit points get set to whatever we have as our max hit points. So the current hit points will be set to 10. And let's say if we change our health, let's also do it so that we actually print out our new health here. So we'll do just to have it a little bit cleaner, we'll type in, make a format text here. We'll type in remaining hit points, colon, and then a squiggly bracket, and then HP and end squiggly bracket. That gives us an input. We can drag our current hit point into that. We'll remove this tick so we get some more space. We'll take this output and put it in our print node. So now every time we are taking damage, it should be calling our change health, which should be printing out our current health, and then it should also be checking if we're dead at any point, and if we are dead, it should be typing out we are dead. Let's try this out. So we walk into the volume, we can see our hit point is now ticking down. So we actually have a hit point system that's actually working. And then we died. Now it keeps going on, of course, so that's something to keep in mind with, but we have a starting point at least. Now, when this event happens that it is dead, you might want to actually communicate it back to the owner of this component that it is dead now. Something should happen. If it was a tree that you reduced to 0 hit points, maybe it should fall over and then do an animation of breaking up and then despawning or something like that. If it's a character, maybe it should fall over and lie on the ground or something like that, depending on what kind of functionality that you want. So here again, we would probably want to have something to communicate via an interface. So if we say in our Blueprint interface here that we want another function called isDead, or actually died, maybe, like so. and we don't have to have any inputs or anything like that. We can go back to our third person character, and actually we go back to our hit point system first, and then we say get owner, and we use the died message. So you can see that it's a blueprint interface call because it has the little letter up there in the top right also. So we're gonna send to our owner that we died if this happens, and that's all good and fine. If we were to do this now with our current example, nothing would happen because the third person character isn't actually implementing that interface yet. So if we go to the third person character, go to our interfaces, find the died button or the died interface, we can now implement this event, and we can say that when this happens we should destroy our actor maybe. So let's try that. We run over here, we start taking damage, it's ticking down. And we reach 0 and our character is destroyed. Or it could have been using the animation now. This is the point where it would be checking against that. So this is basically how easy it is to make a component. And these can be as advanced or as complicated as you want them to be. You can have super advanced things, like you can have, for example, something that's not too uncommon is something like an arsenal, where you have on a character, you have a component which actually contains all of the weapons that the character is walking around with. Or you can have a component that specifies which kinds of animations and attacks it can perform, or a component that keeps track of your abilities so that you only from the character blueprint send an input to the interface saying through an interface or to the system saying I am doing this, and the actual component interprets this as a light attack or a heavy attack, and gives you feedback if your cooldowns are up or not and things like that. So there is a lot of cool things you can do with a component system. With that said, you might want to be a little bit careful about components, because it is, once you start making components, it's easy to just feel like you should do everything as components. There is a bit of a performance cost when it comes to components. Something like if you have a lot of different actors in the world with a lot of different components on them, that can get problematic in the performance front. I'm not sure exactly what specifies as too many, either when it comes to actors or components when it is related to this, but just something to keep in mind, that you don't want to go too crazy with it and do too many. Try to be a little bit Spartan about it. Yeah. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you might have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.